It's been a while now that I've been off due to some circumstances that are beyond my control. I'm very, very excited. In fact, super excited to welcome you back to our online lesson. All right, let us welcome ourselves with this very interesting question. For my WAEC candidate who just concluded their WAEC exam this week, or we shall be concluding their WAEC exam this week, this was our question number 2 in our objective test. Question number 2 in our objective test. So, I don't know how you felt about it when you saw this question. This question is very, very simple. This is a very, very simple question, but very, very tricky. So I'm going to show you the shortcut on how to approach such a question whenever it comes up in any exam again. I know some of you may be aiming to write JAM or post-UTME next year. So if a thing like this comes up, so that you know how to tackle it. Alright, this question is just simply based on periodic table. I want to give just few preamble about the periodic table. We already know, for those of us who are into chemistry or are science students, that one of the major or most classification of in science is the classification of elements into different groups and periods. So in chemistry, there is a table or there is a chart called periodic table. And what do you mean by periodic table? Periodic table is not just an ordinary table that one can see down. It's just a chart. In fact, the tabular arrangement of elements into vertical sections and horizontal columns. Alright? Or we can say that periodic table is the arrangement of elements in an increasing order of atomic number. That is, whenever you arrange elements in how their atomic number increases, what you are doing there is what is called periodic table. Alright, so let us take a look at the question in this way. So the question says, in the periodic table, an element with electronic configuration of 1s2, 2s2, and 2p3 is in which group? Sorry, there's a mix up there. Is in which group? So, since in the periodic table is arranged like this. Let's say this, something of this nature. So the periodic table is just kind of a tabular arrangement like this. Okay, so we have horizontal columns and we have vertical columns. These ones here, the vertical columns here are known as groups, whereas the horizontal columns here, or the horizontal sections here are known as periods. Alright, so they are asking us to which periods will this element that has the electronic configuration 1s2, 2s2, 2p3 will belong. Because it must belong to a period and it must belong to a particular group. So which period will this element belong? Alright, there are two ways. Two simple steps to know the period or the group to which an element will belong to. Let us just come close, let us show ourselves. The first way to know is for you to draw the Lewis diagram of that atom. Alright, so from the look of things here, we are going to know the atomic number of this element from counting or by counting the number of electrons or by the number of these passes on top of these letters. So we have 2 plus 2, 4. 4 plus 3 is 7. That means the atomic number of that element is 7. So let us come close. Let us draw the Lewis diagram. If we are to draw the Lewis diagram of this atom or this element, we are going to say the first shell should take 2 electrons. The first shell of any atom must carry a maximum of 2 electrons. And that shell is usually called K shell. Okay, so the second shell now carry the whole or the remaining electrons, which is 5. So the first one should be here. Number 2, 3, 4, and 5. Now, how will this diagram, this is the L shell, how will this diagram help you to know the period and the group to which an element belongs to? If you draw the diagram or the Lewis structure of any atom, the number of electrons in the outermost shells, that is the last shell as you are drawing the diagram, the total number of electrons there tells you the group to which that element belongs. Whereas the number of shells of that atom or that element tells you the period to which that element belongs. Let me start again. I said if you can draw the diagram of any atom or any element, the number of shells there, if it is 1 shell, that means that element is going to belong to period 1 of the periodic table. Whereas if it is 2 shells, that means it's going to belong to period 2 of the periodic table. If it is 3 shells, it is going to belong to period 3. If it is 4 shells, it's going to belong to period 4. Alright? And then I also say that the number of electrons in the outermost shell, as you are drawing the shells, the number of electrons, the total number of electrons in the outermost shell tells you the group to which that element belongs. So let us see, let's just say, okay, let's take from period. Period. I'll say the number of shell tells you the period. Since we have this is the first shell, this is the first shell, and this is the second shell. So that means that it will belong to period 2 because it has two shells, the K shell and the L shell. Okay, let me go to group. And I've also said that the total number of electrons in the outermost shell, which we refer to as valency shell or valency electrons, tells you the group to which it belongs. Let us count the total number of electrons. 1, 2, 3, 4, 5. So this will mean that this element is going to belong to group 5 of the periodic table. Remember, usually in the periodic table, we use numbers. Okay, so the periods are usually depicted in Arabic number, okay, or our real number, or not usual number. But the period, sorry, yes, the periods, but the groups are written in Roman numerals. I1, I2, I3, IV. So you can see something like 1, 2, 3, IV, 4, 5. So you can see from our explanation, this element must belong to period 2 and group 5, which means that our answer option C is correct. Sorry, not C, not C. Option D is correct. Period 2, group 5. Period 2, group 5. Let me show you another way. I want us to see another way of answering this question. Another way we can answer this question is, okay, let me bring out the electronic configuration. 1s2, 2s2, and 2p3. Now, we already know from our electronic configuration that the s orbital can carry a maximum of 2 electrons. The p orbital can carry a maximum of 6 electrons. The d orbital can carry a maximum of 10 electrons. Whereas the f orbital can carry a maximum of 14 electrons. Now, since our configuration shows that the last orbital here is p, and it is not complete, it's not up to 6, how do we know? How do we know the period to which this element belongs? Now, of course, this one S here is the first shell, which of course, anytime you are drawing, you draw it this way. These 2 electrons are going to be in the first shell, which is K shell. Okay, these 2s and these 2p means that they are in the second shell, which is L shell. So the number before the letters there tell you the energy level or the shell. Alright? So these 2s and these 2p belong to this same shell, which is L shell. So these 5 electrons there, like we did in the previous one, are going to be in the second one. Now, the number of shells here, which is 2 now, tells you the periods, which of course we are saying that is going to belong to period 2. Because we have one shell number 1 and shell number 2. These 2s and 2p are in the second shell, which is L shell. Alright, or in the second energy level, which is L shell. So that accounts for the fact that it is going to belong to period 2. Then let us come to group. How do we know the group to which it belongs? Since P can carry a maximum of 6 and it is not complete, what we will simply do is that we are going to add the electrons in the second orbital together with the electrons in the next orbital, please. The electrons in the 2s orbital and 2p orbital, add it together, then it's going to give us the group number or the group to which that element is going to belong. Let me say that again. Since the maximum electrons that P can carry is up to 6, and in this configuration, it is not complete. So for us to know the period, the group to which is going to belong, simply add the electrons in this, the whole of this shell here or the second orbital here. Add it together, the total electrons there tells you the group to which it belongs. Which of course, if you check very well, 2 plus 3 is going to give us 5. That further shows us that this element must belong to period 2 and group 5. This element must belong to period 2 and group 5. Please, if you have any question on how to recognize the period or the group to which an element belongs, or anything about electronic configuration, IC electronic species, please do well to follow my video on YouTube, Eugene TV. Follow me also on Eugene TV 101 on TikTok, or you can also follow me on Facebook as well. Thank you.